Now in the previous session we have seen what are stacks. In this session we are going to see some animation related to stacks. Okay, and this is a very good animation which I generally appreciate because whenever I teach my students what are stacks, what are linked lists, then these animation actually help us to understand the basic concept. Okay, so what you do is go to your web browser and search data structures visualization. Okay, then if you see data structures visualization, then in that case you'll get some link. So this is a link. You are going to open this link, and then in this website on the first 4 links are related to stacks and queues. So I'm just going to open these links, and then we are going to see the implementations of stacks and queues. Right, so this is an array implementation of stacks. Here top is pointing to 0, so as you can see here top is 0 initially. So let me just zoom it up for you a little bit, right, and let me just decrease some animation. Okay, animation speed. So if I insert 2, then if I click push, then this 2 will be inserted onto the stack, and this top will be pointing to the next location now, right? So as you can see, this top is always going to point to the location where the next data will be inserted. Okay, now if I insert, let us suppose 67, then 67 will be pushed into the stack. Now let us suppose we insert 89, then 89 will be pushed into that position where top is pointing, and then it is going to increment the top. Okay, so now let me just increase some animation speed. So if I insert 45, then 45 will be inserted into the stack. If I insert 4545, and this will be inserted onto the stack. Okay, now if we pop some data, in that case top will be decremented first. So top, right now top is 5, so what will happen is top will be decremented to 4, and then it is going to take the data which is present at the location, and then it is going to return the data. Okay, so if I click pop, so it is going to decrement top, and then it is going to take the data which is present at that location, and then it is going to give us the data which is just popped. Okay, so if again click pop, right, so this is how the push and pop function is working if we are using an array. So let us try to fill this complete array, and let us try to see what happens if we completely fill this complete stack. Okay, so I am starting 1 2 3 4 5 6 7 8 9 10 11, again 2 3 4 5 6 7 8 9 1 2 3 4 5 6 7 8 9, and then again 1 and again 2. Now if I insert anything, then it will not be inserted because stack is completely full. I cannot insert any other data now. Okay, so in this condition is called a stack overflow. Okay, now if I try to pop some data, I can easily pop this, so it will always going to give us pop value. So let me just clear the stack. Right now the stack is completely clear. Now even if I try to pop something, it is not going to do anything because this condition is called as a stack underflow. Okay, so this is an array implementation of stack. Now let us see the linked list implementation of stack. So in this linked list implementation of stack, top is a pointer which is going to point to the initial node of the linked list. Okay, so initially if I insert, let us suppose 1, okay, and then I push that 1, then a node will be created and top will be pointing to that node. Okay, now if I insert 2, that means a node will be created which will be containing this value 2, and this node will be added to the front of the linked list. Okay, now if I insert, let us suppose 56, then this push function will create a new node, and that is going to return new data. Okay, now whenever you are using a linked list implementation, in that case you do not have to worry that your stack is full, right, because the stack will be full only when you do not have any space onto your computer, onto your memory, right? The size of the array in case of in size of array is already fixed, right? So whenever you are writing a program to implement stacks using array, in that case the size is already fixed. You cannot increase or decrease the size of the array while you are running your program. But in case of linked list implementation, the size can be increased or decreased according to your requirements. Okay, now let us try to see array implementation and linked list implementation of queues. Okay, so this is the array implementation of queues. So in queue we are having two operations. one is NQ operation and another one is DQ operation. Okay, which we'll be seeing in a moment how to write this program for NQ and DQ operation, right? So in case of stacks are generally called as the first in last out data structure or last in first out, because both these words terminologies are used for stack, that is FILO or LIFO. Okay, FILO means first in last out and LIFO means last in first out. So both these terminologies are used for stack, but in case of linked queues, the terminology which is used is FIFO, that means first in first out, or you can even say last in last out, LILO. Okay, so in queues, if we insert some data, for example, if I insert 23, then this will be an NQ operation and it will be inserted at the position where tail is pointing. Okay, now let us suppose I am inserting some other data which is 333. Okay, then this 333 data will be inserted onto the queue and the value of the tail will be incremented. Okay, so in case of array implementation, tail is always going to point to the location where the next data is inserted. Okay, it is actually dependent on your program, right? It is not dependent on what tail should point or where the tail should point. We are mainly concerned with the functionality. In case of stacks, in case of queues, we are mainly concerned with the functionality. Don't bother, don't be confused when you see multiple different implementations of stacks in multiple different books. In some cases, tail is going to point to the last node, last data, and in some cases, tail is going to point to the next location where the next data will be inserted. Okay, so this is a point where students generally confused. Okay, now if I insert 67, then 67 will be inserted onto the queue. Okay, and head is pointing to the 0th location, that is where the front data is, where the first data is. Okay, now if I DQ, then head will take this data and this head value will be incremented. Okay, we'll be seeing how to implement this stack and why the head value is incremented, why all this data is not shifting to the next location. Okay, now let us see a linked list implementation of queues. So in queues, linked list implementation means whatever data we are going to insert, that data will be added into the last of the linked list. Okay, and whatever data we are going to DQ, that front data will be popped. Front data will be DQ'd. Okay, now if I insert, let us suppose 778, then this node will be added to the last of the linked list, and the tail pointer is going to point to this node. Okay, now if I insert 888, now let us insert 8888, so on. Right, as you can see, please follow the order of operations which they are doing, because this order of operation is important. So let me just decrease this speed a little more and let me just try to insert 67 here. So whenever we are inserting 67, in that case, first of all, we are going to make this last node point to the newly added node, and then we are going to make the tail point to this newly added node. Okay, so this is very important whenever you are writing the program. Correct? So if I DQ, that means front data will be DQ, and this head is going to point to the next node. Okay, so this is the queue implementation, linked list implementation of queues. Now let us try to write the program related to these queues, because we have already written the programs related to stacks. Okay,